Hi everyone, welcome to Focal Academy. See this problem. Here open loop transfer function given here, that is g of s h of s. Now how can you find the phase crossover frequency for this function? This is the problem. So first of all, what is phase crossover frequency? So whenever if you find the phase angle for the given function, that is phase angle for g of s, h of s, if you get minus 180 at certain frequency, that frequency is called as phase crossover frequency. So let's see here. So replace s with j omega, g of j omega into h of j omega. The phase angle is minus 180. So here frequency is there, omega. So at certain frequency, the phase angle is minus 180. So let's consider that frequency is called as phase cross frequency, that is omega pc. So at that frequency only we will get the phase angle is minus 180. So that frequency is called as phase cross frequency. So first of all find the phase angle, then equate to minus 180. So from that we will get omega pc value. So let's see here how to solve. So first of all replace with j omega, that is s value. So that becomes so g of j omega h of j omega, that's equal to 1 by, so s means j omega into 1 plus j omega by 2 into 1 plus j omega by 10. So when you observe here, this is one complex number, this is another complex number, this is another complex number. So in numerator it can be written as 1 plus j0. This is also one complex number. Now how can you find the phase angle here? So let's observe here. So whenever the function will be like this, so this is the phase angle. Means for this complex number find the phase angle, that is tan inverse of b by a plus phase angle of this, that is tan inverse of d by c. So sum of all the phase angles on the numerator minus of sum of all the phase angles for the denominator. So this is the process for finding the phase angle for overall function. So this is in this format. Now we can easily find phase angle, that is phase angle for this, it becomes, so this is a complex number. Now the phase angle is here, complex part is 0, real part is 1, that is tan inverse of complex part by real part, that is 0 by 1. There is no more complex numbers are there in numerator. Now minus of sum of all phase angles for the denominator, for this phase angle, for this phase angle, for this phase angle. So we can get here, that is tan inverse of, it becomes here 0 is the real part, that is omega by 0 plus sum of, now for this tan inverse of, this is j and this is omega by 2, that is real part, so omega by 2 by 1 plus for this phase angle is tan inverse of omega by 10. Here tan inverse of 0 by 1 means 0 only, means tan inverse 0 is nothing but 0. So 0 minus here anything by 0, nothing but infinity, it becomes only at 90 degrees, that is minus of 90 degrees plus, now it becomes tan inverse of omega by 2 plus tan inverse of omega by 10. So that's be equal to minus 180. So whenever omega is phase cross frequency, that is take here omega pc. So at that frequency the phase angle is minus 180. Now equate this, then you get here, so here 0, so apply minus for all these terms, it becomes minus 90 minus tan inverse of omega by 2 minus tan inverse of omega by 10. So here omega is omega pc. So at that frequency the phase angle is minus 180. Or make it as cancel minus without taking common. So keep as it is, no change. So minus will be cancelled here. Now tan inverse of omega PC by 2 plus tan inverse of omega PC by 10, that's equal to 180. So bring this 90 on right hand side, it becomes minus 90. So it becomes 90 degrees. It is tan inverse of omega PC by 2 plus tan inverse of omega PC by 10, that's equal to 90 degrees. Now by using calculator, we will get omega PC value. By simplifying that, we will get root 20 radians per second. So this is the phase crossover frequency. So at this frequency, the phase angle for the open loop transfer function is minus 180 degrees. Now this is the required frequency for the given problem. So this is the process of simplification, and thanks for watching. Please subscribe, like, share. Thanks.